It begins by focusing on the danger posed by volcanoes under which millions of people live, and points out that even distant, forgotten volcanoes can lead to global disasters. Volcanologists, climate researchers, and geologists are trying to learn from past disasters to prevent loss of life in the future. The plague of Justinian and the mysterious trigger. The story begins in 541 AD with the plague of Justinian, which started in Constantinople, Istanbul, decimated the population and caused the deaths of millions. Emperor Justinian and the people did not know the true cause of this invisible enemy. 2. Ice cores and sulfur tracing Greenland. The answer to this puzzle was found 1,500 years later, and 3,000 kilometers north in East Greenland. Researchers led by Johannes Fogg drilled ice cores to study past climate history. Anomaly, the electrical conductivity of the ice, indicated a sudden increase in atmospheric sulfur content in the 6th century. This sharp peak indicated a powerful volcanic eruption and coincided with a period of approximately 2 years. Sulfur and climate. Volcanoes erupt not only ash into the atmosphere, but also sulfuric gases. In large explosions, sulfur is ejected into the air up to 1 kilometer, mixes with water, and forms a layer of sulfuric acid clouds that blocks sunlight. 3. Historical records. The Dark Summer. According to precise records analyzed by historian Misha Meyer, the sun remained weak for months starting in 536 AD. Even in summer, it was like winter crops were weak, wines soured, and birds died before the plague struck the city. This unusual weather, combined with doomsday prophecies, had created great fear among the public. Example 1815. The 1815 eruption of Mount Tambora in Indonesia. The explosion, which lasted only 3 hours, killed 10,000 people. But the sulfur cloud caused widespread famines and cold waves globally, claiming an estimated 10 times more lives. 4. Guilty volcan. Ilopango analyses at the Alfred Wegener Institute in Bremerhaven confirmed the volcanic event in the 6th century. However, the location of the volcano could not be found. Researchers were skeptical about whether there were 2 explosions a few years apart, proximity to the equator, for an eruption that left its mark on both the north and south poles. The volcano needed to be located near the equator. The giant in El Salvador. The Ilopango volcano in El Salvador was blamed on Robert Dole and his team. The explosion was so large that it buried the entire region under a layer of ash, several meters thick. Evidence, by examining ash minerals in sediment samples collected from the Pacific Ocean floor. Geologist Stefan Kell confirmed that the ash came from Ilopango. The area of this explosion was calculated to be 1.2 million square kilometers for times the size of Germany, making it the largest explosion in the last 2,000 years. The time of the explosion and famine. Robert Dole narrowed down the exact time of the explosion using pieces of wood that burned and charred during the explosion, whose age could be determined by the radiocarbon method. Not the 5th century, but the early 6th century. Chain reaction. The 15-year cold snap following the explosion reached Constantinople. Famine broke out and the population weakened. Plague connection. The Institute of Infectious Diseases has confirmed that the bacterium Yersinia pestis plague caused the deaths from tooth remains found in mass graves. Cold weather, famine, and a weakened immune system accelerated the spread of the plague. Rats searched for food in cities and spread the disease to humans through fleas. Result: the Ilopango eruption changed the climate, leading to famine, which made the population vulnerable to plague. This plague may have even accelerated the end of antiquity by weakening Justinian's empire. Vi. Modern risks and preparedness. The text emphasizes that volcanic risk is not a thing of the past. Loki Volcano, Iceland, -1784. Its eruption led to one of the most severe winters in Western Europe, including the smell of sulfur, respiratory problems, floods, and famines. Modern calculations. Today, due to the atmosphere being more polluted, volcanic gases from an eruption like Loki could cause 140,000 more premature deaths annually. The limits of technology. The examples of Galera's Columbia -1993 and Mount St. Helen's USA 1980 showed that even the most experienced scientists can not always accurately predict the course and impact of eruptions. Urban density. Globally, 67 major cities are located near active volcanoes, with an estimated 116 million people living in a hazardous zone, e.g., Tokyo, Seattle, Naples. VII.New monitoring methods. Mount St. Helens is considered the birthplace of modern volcanology. Angela Debok has developed a new method for creating 3D computer models from photos taken using a drone or camera, allowing her to detect even the smallest surface changes on the volcano. This simple, flexible, and affordable method holds promise for volcanoes that are not regularly monitored. This journey, which stretches from historical records to the glaciers of Greenland, and then to the depths of El Salvador, has proven that volcanoes are not just a local but a global threat. The connection of the Justinian plague to a distant volcanic eruption painfully illustrates the fact that every city in the world can be affected by the consequences of a natural event. Across the oceans, sleeping giants like Ilopango, even after centuries of silence, have the power to disrupt the climate, collapse food chains, and leave humanity vulnerable to epidemics. Today, with over half of the world's 7 billion people concentrated in cities and reliant on complex supply chains, the potential impact of such a disaster is far greater than it was in the 6th century. The role and limitations of modern science, prediction, new technologies, such as the lessons learned from Mount St. Helens and Angela Debok's simple, affordable 3D modeling method will allow us to better monitor volcanic activity. Warning, however, as demonstrated by the tragedy at Galaros and the unpredictable side eruption of St. Helens, no matter how advanced technology becomes, it is impossible to fully predict the ultimate movement of volcanoes. Scientists can only provide timely warnings. They cannot stop the explosion. Preparation. The fact that some of Europe's largest metropolises, Naples, Istanbul, or global centers, Tokyo, Seattle, are located in the shadow of active volcanoes highlights the vital importance of national and international disaster plans for millions of people at risk. In the event of cold weather, ashfall, or a volcanic winter, preparations should be made for a major power outage, supply chain paralysis, and the threat of epidemics. Ultimately, the most important lesson to be learned from past disasters is this: complete protection against nature is not possible. However, understanding the mechanisms of past disasters, expanding monitoring networks through global cooperation, and developing comprehensive disaster plans that reduce the vulnerability of modern societies are the only way to protect us from the consequences of a future awakening moment. Even if the danger is forgotten, the power of nature is permanent.